All right, so now we're going to write these in reduced radical form. So the first thing we want to see is that since these are already in exponential form, we can use our laws of exponents to multiply these together. So remember that since these are all multiplying together, we can use our properties of multiplication to rearrange them, right? Because 2 times 3 is the same as 3 times 2, so it doesn't matter what order I multiply in as long as I multiply them all, right? So I can move these around, so it's 4 times 2 times x to the 1/4 times x to the 1/2. 4 times 2 is 8. Now x to the 1/4 times x to the 1/2. Remember this property of multiplying, or of exponents. When I have x to the a times x, so I'm getting ahead of myself, times x to the b, that equals x to the a plus b. Well, we could just add these exponents together, right? So this is going to be x to the 1/4 plus 1/2. And you say, but Mrs. Barney, we can't add 1/4 and 1/2. No, you can't, until they have common denominators. And hopefully, you're pretty proficient in changing denominators that you realize that 1/2 is 2/4. So, man, that is just not writing very well. 1/4. And so we end up with 8x to the 3/4, because 1/2 is 2/4 plus 1/4. There we go, 8 to the 3/4. 8x to the 3/4, excuse me. Oh, and this asks for reduced radical form, so I knew there was one more step. So we need to write this as a radical, so this is 8 times the 4th root of x cubed. And that's it. So when it says reduced radical form, it means write it as a radical, okay, not as an exponent. Okay, so this one, remember our properties of exponents say that if we raise something to the power, we bring that and we multiply it by each exponent. So this is 2x to the 2/2 y to the 1/2. So we simplify that to be 2x y to the 1/2. And now since we want it in radical form, that just equals 2x times the square root of y. All right, so this one's a little bit more challenging because it's a fraction. So the very first thing that I do with fractions is I check to see if there's anything that simplifies, because it's a lot easier to simplify before we make it a radical than after. But in this case it doesn't, because 25, the only factors of 25 are 5 and 5, and the only factors of 121 are 11 and 11, so they have no common factors. So then we just go ahead and remember our properties of exponents tell us that this 1/2 just applies to every single number, or they're not terms, but every single thing inside of this, okay? So we're going to do 25 to the 1/2, we're going to do x to the 6 to the 1/2, so we're going to write this like this, 25 to the 1/2, x to the 6/2, because we multiply those together, then we have 121 to the 1/2, and y to the 20/2. So then we just simplify that. What's the square root of 25? That's 5. X to the 6/2 is x to the 3rd. 121 is 11. And then y to the 20/2 is y to the 10th. And then we're asked to write this in radical form, but guess what? There are no radicals left, right? There's not a single fraction in the exponent, so there are no radicals. So this is our final answer. All right, now this one again, we apply everything. So we go, this equals 3 to the 1/2, x to the 2/2 over 12 to the 1/2, x to the 5/2. So we have 3 to the 1/2 because that doesn't simplify, and then x because 2 over 2 is 1, and then 12 to the 1/2, x to the 5/2. Oh, and do you know what I forgot to do before? Just kidding. Let's go back. I was like, man, this is way messier than I remember. I forgot to do exactly what I just lectured you to do a second ago. Like literally less than a minute ago, I told you, simplify the fraction first, didn't I? I said simplify the fraction first before you do the radical, because it's so much easier. And here we are. Let's simplify this first. Okay, so this 12 is the same as 4 times 3. And since there's a 3 on the top and a 3 on the bottom, they cancel out. Since there's x to the 5th on bottom, x squared on top, the x squared cancels out two of those, and we have 3 left. So in the end, we end up with 1 over 4x cubed to the 1/2. Now that 1/2 applies to everything, so 1 to the 1/2, 4 to the 1/2, x to the 3/2, and then we get 1 to the 1/2 is just 1, 4 to the 1/2 is 2, x to the 3/2 is x times x to the 1/2. So we can simplify this even further. This is 1 over 2x times the square root of x. And we have a little problem here because we have a radical in the denominator. You know, we don't like those radicals in the basement because we just don't know what they're planning. So we multiply both the top and bottom by that radical to get rid of it. So we end up with root x over 2x times root x, which is just x. Okay, so we get root x over 2x times x, which is root x over 2x squared. So that is the final reduced radical form. So we know it's reduced because it doesn't have anything else that can simplify. It doesn't have anything, any radicals in the denominator, and everything is in radical form, not in exponential form. All right, we're going to reduce these ones now. So the square root of 18x to the 4th, y to the 9th. So we could, there's a couple different ways we can do this, but let's do it this way. 18 is 3 times 3 times 2, because it's 9 times 2. And then this is x to the 4th, y to the 9th, 3, 4, 5, 6, 7, 8, 9. I'm rethinking my decision on which way to do this one. That's okay. So we take out groups of 2, because this is a square root. And what do we have outside? We have 3x squared, y to the 4th. And what's trapped inside because it doesn't have a partner? 2y. Okay, so that's the one way to do it. The other way we could have done it is with fractional exponents, which in that case probably would have been faster and simpler. So yeah, if you have like a fractional exponent that's like to the 20th, please do not list out 20 of them. Try using fractional exponents, okay? All right, first things first, we always simplify. 48 divided by 3 is, goes in 1 time, 1 left over, 16. I knew that. X to the 5th over y squared. Okay, now we can simplify, and now we can take the radical top and bottom. Remember, a big radical like this takes the square root of the top and the square root of the bottom. So this is the square root of 16x to the 5th over the square root of y squared. That makes it a lot easier, right? And remember that top one is the square root of 16 times the square root of x to the 5th over the square root of y squared. And then we know square root of 16 is 4. The square root of x to the 5th would be x squared, and there'd be 1 x trapped still in there because there's 2 groups of 2 that could come out. And then 1 x stays trapped, and the square root of y squared is just y. Okay, 256, 5th root of 256. So we're going to go ahead and do our prime factorization of 256. So that's 2 and 24, oh yeah, 128, yep. And then that's 2 and 64, and that's 2 and 32, and that is 2 and 16, and that is 2 times 2 times 2 times 2, because 16 is 4 times 4, so we can just go ahead and do that. So the prime factorization is 1, 2, 3, 4, 5, 6, 7, 8 2's. So this is 2 to the 8/5, x to the 3/5, y to the 9/5. And then we can simplify that. 2 to the 8/5 is 2 times 2 to the 3/5, right? Because there's a group of 5 that can come out, and then there's 3 more fifths left over. And then this is still x to the 3/5. And that would be y times y to the 4/5. So how do we write that in reduced radical form? Well, what still is a radical? This is still a radical, this is still a radical, and this is still a radical. So that goes underneath the radical symbol. 2 cubed x cubed y to the 4th. And what is not still a radical? That is not still a radical. That's outside, right? We took those out because we took the 5th root of them. So that is 2 times y on the outside. Okay, let's look at this one again. We simplify before we do anything else. So 27 divided by 3 is 9. X cubed divided by x is just x squared. And so now we just have the square root of 9x squared, which is the same as the square root of 9 times the square root of x squared. So that is 3x. All right, now we're going to multiply some radicals. Woohoo! Okay. So, remember to multiply radicals, they have to have the same index because, I'll just show you. So this is the same as 4 times x cubed to the 1/2 times 3x to the 5th to the 1/2 times 3 to the 1/2. So you see they're all to the 1/2, so it's okay for us to combine them together. If they weren't all to the 1/2, it wouldn't be the same, right? Because we know that if I have like a b to the 1/2, that's the same as a to the 1/2, b to the 1/2. So I can go the other way, right? If I have a to the 1/2, b to the 1/2, I can combine them all together into 1. So I can combine these all together and I get 4x cubed 3x to the 5th times 3 to the 1/2. And that'd be the same as combining them all under a radical. And that is 4 times x to the 8th times 9 to the 1/2. Oh, and now this is really easy, right? So this is 4, 9 to the 1/2, x to the 8/2, which is 4 times what's 9 to the 1/2? Well, that's 3. X to the 8/2 is x to the 4th, so that is 12x to the 4th. All right, same thing here. Since they all have the same index, then this is the same as, we can combine them together. So this is 2x cubed times 16x to the 4th. We are only taking things that are under the radical. So those are the only things that are raised to the 1/4. And then this 4, see, it's not taking the 4th root, so that stays out here. Okay, and so then we just go ahead and combine things together. So let's see, we have 2 times 16 times 3. So 16 times 3 is 48, times 2 is 96. You'll probably catch me if I do the math wrong. That's 7, and then that's x to the 8th to the 1/4. Okay, and then this is easy because we can just go ahead and apply that 1/4 to everything inside the radical. Let's make sure we got 2 times 16 times 3. 2 times 16 times 3 is, sure enough, 96. Okay, and does that have a perfect 4th root? Is that a perfect 4th root? It is not, so we're going to go ahead and have to figure out what stays and what goes. So this is 4 times 96 to the 1/4 times x to the 8/4. So that's 4 times 96 to the 1/4 times x squared. All right, now we got to figure out this 96. I didn't quite leave myself room, so I'm just going to go ahead and do it right here. So we have 96. Well, we know that that is 32 times 3. 32 is 16 times 2, and that is 2 times 2 times 2 times 2. So we could rewrite this as 4 times 2 to the 5th times 3 to the 1/4 x squared. There's other ways to write it, but we're just going to do that because, it's 2 to the 5th. So that's 4 times 2 to the 5/4, 3 to the 1/4, x squared. And then, I've only got 15 seconds left. So this ends up being 4 times 2 times x squared times the 4th root of 2